So projectile motion is when objects fly through the air. Something is launched or shot or thrown into the air, then we can use a projectile motion equation, which you'll see on the next page. And we want to be able to find the maximum height of the object. That's always a useful thing. And we want the maximum, then we want to use and find the vertex, which is what we were doing yesterday. And then sometimes we want to know when the object lands on the ground. How long does it take for the object to hit the ground? And that's where it would fall on the ground here, where we have a height of 0. And to do that, we find the zeros. To find the zeros, we use the quadratic formula. You'll notice they both have the negative b over 2a part, okay? They are very closely related. And so these two formulas are what we're doing today. The vertex, finding the x and plugging it back in, and then using the quadratic formula to find those zeros where it hits the ground, okay? So I need you to copy down all of this. This is the only example we're doing today. Please write all of it. I locked the bathroom. All right, example 1. Use S of t. S of t equals, quiet please, negative 16t squared plus v naught t plus s naught. Oops, I highlighted too far. To answer the following. All right, this v naught t, this is standard notation in physics. V stands for velocity, and v sub 0 means initial velocity, means the starting velocity when time is 0, right at the beginning. How fast was that ball launched from the arm of the pitcher? Okay, and then S naught. Again, the sub-0 represents the initial or starting. They use S. I don't understand why they use S. But S represents the initial position. Or I would say height. Okay, so we're really finding the position of an object, or its starting height. We're finding the height. So their S represents initial position, but we might consider it as height of the object, okay? Height above the ground. Negative 16 represents the force of gravity pulling that object back to Earth. That would be negative 16 feet per second squared. That's acceleration due to gravity. This is a fairly good equation for finding the maximum height and how long it takes for something to fall to the ground. It doesn't include like how heavy or how dense the object is. It doesn't include like wind resistance or anything like that. It's a pretty basic equation, but for small values of time, it works pretty well. So we have a ball that is thrown into the air straight up with an initial velocity of 96 feet per second from a cliff 200 feet above a beach, okay? Very important information here, information that we're going to plug into our model. But before we do that, I want to draw a little graph so we have an idea of what's actually happening. And so you can imagine a little picture here. This is my cliff. And we've got a ball right there that is now 200 feet above the ground, or the beach in this case. And it's being launched into the air, straight up, really. It's going to go straight up and come down. being launched straight up at 96 feet per second. And then what's going to happen? Is that ball going to go up forever? No. What does it do? It falls down to the ground. Sure. And it does fall down to the ground, and it's going to land on the beach, where it has a height of 0 feet. That's when it lands, okay? Started at 200 feet above the ground, and it would land and hit down here where its height is 0. What does this horizontal axis actually represent? Well, we use X usually, but it's a very generic X. You'll notice our equation here. It doesn't have any X's. What does it have instead of X's? T's. That's exactly right. So we don't have an X-axis. What do we have? T. And what does T represent? Time. Very good. So we have a time axis, and that's really, really important. We also don't have a Y-axis. Instead of Y, we have S of T here, which really just represents the height or position of our ball, okay? The height above the beach. All right. And you'll notice that we have this shape here. What's this shape that the ball takes? What is that called? Parabola. Yeah, that's what we did yesterday. It's a parabola. It's a down parabola. Why is it a down parabola? Yeah, because it has that negative value in front. That makes it an upside down parabola. All right, so the first thing we want to do is we want to write an equation. So we're going to plug in the values for the velocity and the initial position. So I have S of T equals negative 16t squared. What is the initial velocity of this ball? I underlined it. What is the initial velocity of the ball? 96 feet per second. That is the initial velocity, so we're going to plug in the 96. It has a t next to it. Plus, what is the initial position of the ball? 200 feet. 200 feet above the beach. 200 feet above the ground. You'll notice the units. Velocity units. Velocity is just speed. How fast someone's going, like miles per hour, or in this case, feet per second. All right. Position are just height units or length units. So we see 200 feet. All right. So pay attention to units because they help stuff be placed where it should go. Now we have this great equation. What is the value of A? Negative 16. What's the value of B? 96. And what's the value of C? 200. Okay. So the first thing you guys need to do is write your equation based on the reading, and then figure out your A, B, and C. And then we're going to answer a couple of questions. The questions are exactly the same, ladies and gentlemen. Do what we do in notes. All right. What is the maximum height of the ball? What do they want to know if they're asking about the maximum height of the ball? Where does that occur on my picture? At the very top. This is also known as the, starts with a V. Vertex. If they're asking what is the maximum height or the highest point or how high does it go, they want to know what is the vertex, okay? We know how to do that. Find the vertex. This is what we did yesterday. How do I find the x-coordinate of the vertex? You just copy down the formula in your notes, ladies and gentlemen. Have negative b over 2a. Opposite of b over 2a. Good. Now, I don't have an x. What do I have instead of an x? T. We're not finding x. We're finding t. We don't have any x's. We just have t's. All right. So the opposite of b. What's the opposite of our b? Negative 96. Very good. Over 2 times a. What's the a value? Negative 16. Very good. And then negative 96 over, what is 2 times negative 16? Negative 32. Ladies and gentlemen, I don't want any fractions today. You need to use your calculator. So get out your calculator and give me decimal answers. What do you get when you divide? 3. We're solving for t, so what are the units then? 3 seconds. Very good. All right, so there's 3 seconds. Does that give us the maximum height? No, that is the time. That gives us 3 seconds. So what do we do to find the height? Plug it back in. So we're going to go to our equation, and we're going to find s of 3. Plugging in the 3, negative 16 times 3 squared plus 96 times 3 plus the 200. And what are you going to do with all of this stuff? Put it in your calculator. Yes, that's what they're for. You absolutely need your calculator. You're going to get real life numbers here. They're not going to be pretty all the time. They're going to get big. They're going to be decimals. You're going to plug it into your calculator. And what do you get when you plug it into your calculator? What do you get when you plug it in your calculator? 344. 344 feet. We're talking about feet here. What is the maximum height of the ball? 344 feet above the beach. That is the maximum height of the ball. 344 feet above the beach. Okay? Our vertex is at 344. So the first question is just what we did yesterday, finding the vertex. Now, the second question's asking us, how long does it take the ball to land on the beach? What are they asking us to find? Time. How long implies how much time it takes the ball to land on the beach. Right here is where the ball lands on the beach. The problem is, this parabola actually continues this way as well. There are 2 answers of where the ball lands on the beach. We need to find both of them, but one of them is not going to be a good answer. Why do you think one of them is not going to be a good answer? It can't be negative. Yeah, over here is an answer that might be negative. Does time ever get negative? No, I wish it did, but it doesn't. So, all right, to find these points is where the height is 0. These are called zeros. So we want to find the zeros, and to find the zeros, we use the quadratic formula. What is the quadratic formula? X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right. Again, though, we don't have an x-axis. What do we have instead of an x-axis? T, time. So this is solving for the time to get the ball to land on the beach. All right, so let's plug in our information here. T equals the opposite of b. What's the opposite of our b? Negative 96. Plus or minus the square root of, all right, the b squared minus 4ac I like to do in my calculator first. So b squared minus 4ac would be b squared, 96 squared, minus 4 times negative 16 times 200. And I'm going to do that in my calculator. So we have 96 squared minus 4 times negative 16 times 200. And I am just literally typing in the whole thing. And I get a very large number, 22,016. That is under my radical. All over 2 times A. What is 2 times A? Negative 32. 2 times negative 16 is negative 32. So you can do a lot in just on your calculator, one step. Now, all of these are numbers. So this is where we have to separate it into 2 things. That, again, we can use our calculator for. So the first thing is negative 96 plus, I'm taking the positive sign, the square root of 22,016. And I'm going to plug the numerator into my calculator. Negative 96 plus the square root, negative 96 plus the square root of 22,016. So I'm going to get the numerator, and it's a decimal, 52.38 roughly, over 32. And now I'm just going to hit divide by negative 32. And my calculator is just going to use my answer, divided by negative 32. And I'm going to get, negative 1.6, 4 seconds. Is that a good answer? No, why? It's negative. Yeah, that happened before time started. That doesn't count. All right. So now we try the other side. What's the other equation that we get from this answer? Negative 96 minus the big square root. So again, using my calculator, negative 96 minus the square root of 2216. Hit enter, we get a big negative number, negative 244.38. And now I'm going to divide it by negative 32. And a lot of this you can just do on your calculators, ladies and gentlemen. And we get 7.64 seconds. So we're going to round to the hundreds place. That's a nice positive answer. It was 7.64 seconds for that ball to land on the ground. For the ball to hit the beach. Okay. So these are 2 really good formulas that give us some important information about a lot of physics stuff. Okay. All right, ladies and gentlemen, you are doing this exact same thing on your worksheet. You have 4 to do. I will pass that out.